All right, guys and girls, I wanna head back through this stuff. So I was gonna check this assignment off, but I'm pretty sure having a 4-day weekend, most of you didn't do it. So rather than be a glutton for punishment. All right. So this is 5.2. I want to go through it. I'm going to go through some of them. So this 5.2, it says it's used in the Z table. So let's refresh.
Oh, I remember this.
So a Z table, a Z score just tells you how far above and below the average you are as a standard deviation. Now, remember, standard deviations can be 0, 1, 2, 3, or 0, -1, -2, -3. If it's negative, it's to the left of the average. If it's positive, it's to the right. A Z-score, a lot of times, is a decimal amount. Okay, is that all right? So, if I had, so on 5.2, we could probably run through this. We could say, hey, we have an average. You remember, we're going to use Greek letter mu now for average. For some reason, things have changed. Mu. So 60 milliseconds. Standard deviation, which is speed, is 10 milliseconds. Okay. So what I want to do is I want to create the normal curve off of the information we know off here. Realize if we're talking about one standard deviation, you have 68% of your population that falls within one standard deviation of the average. 95% falls within 2. 99.7% falls within 3. And then if you go all the way to 4, it goes up to like 99.9%. So the area under the normal curve is approaching 1. So if I draw my normal curve to look like this, I do have 60 being here. If I go one standard deviation, what value is that then? 12? Not quite. What do you guys think? 70? What's that one? What's that one? Oh, you guys are so smart. And then if I go this way, what's this way? 50? And then? Okay, so 99.7% of our data should fall within that range. Okay? But then our Z-score talks about this. Our Z-score will fall somewhere in here. It doesn't have to fall on the exact standard deviation. And then the table A at the back of your book will tell you how much of your population falls to the left of it. Okay? So it says from here, it says what proportion, this talks about these airbags and they're inflating in a certain amount of milliseconds. What proportion of airbags will take longer than 72 seconds? So longer than 72 seconds. So 72 is like right there. Do you agree? So the area here is our longer area. Do you agree? So what 72 milliseconds, what will take longer than that to inflate? So what I'm going to do is I'm going to find the Z-score first. Okay? The Z-score, if you remember, is the observed minus the average over the standard deviation. So they want to know what's going to happen at 72. So I'm going to plug 72 in for x bar minus our standard deviation of 60 over minus my average over my standard deviation. So I'm going to wind up with 12 over 10. So I wind up with a Z-score of 1.2. Okay? So from there, I need to go to the flip to the back, find my table that has the Z-scores on it. Remember, the Z-score finds me the area to the right. So I'm going to look up the 1.2 standard deviations above the average. 0.8849. So this is going to yield us 0.8849. So what does that value mean then for us in response to this question? The 88.49% of the population falls underneath this. Shh. Some of you are talking too much. I know you're excited because you haven't seen each other all weekend, all 4 days. So, what is this? What is this in reference to? Which part of my picture? My shaded portion or my non-shaded portion right now? Non-shaded. I want values that are bigger. I want values that are bigger than this. So what percent of my data is going to be larger than that? So I'm going to go 1 minus 0.8849. So 1 minus 0.8849. Help me out. 0.11. Okay? So what proportion of the airbags will take longer than 72 milliseconds to inflate? 11.51% of my airbags in this scenario will take longer than the 72 milliseconds to inflate. Okay? If I go to letter B is done the same way. Again, it's talking about longer. That came to an answer of 0.02. What proportion of the airbags will take less than 60 milliseconds? Well, 60 milliseconds is the mean. It's a normal curve. The mean and the median are the exact same thing. So, what percent will take less than 60 milliseconds? 50%. What will take more? 50. Okay? What proportions of the airbags take longer than 55 milliseconds to inflate? So 55 milliseconds would be here. Okay? Again, you want the area all over here. So you're going to find the Z-score. So that comes out to a 55 minus 60 over 10. So that gives me negative 5 over 10. So negative half or negative 0.5. Should that score be negative? Why probably? Okay, go a little more specific, English major. What does a negative Z-score mean? It's below the average. Good, so it's to the left of the average. So does a negative 0.5 Z-score fall within the original 65 or 68% of our population? And how do you know? Why? Because that's still there. You're right saying it, because 50 to 70 will encompass 68% of our population. We are above. We have a score of 55 that we observed, which is above the 50, which means it falls within one standard deviation. The average, we happen to be a half standard deviation below our average score. And then you can easily find that Z-score on there, and that's going to come to 69.15% inflate at more than 55 milliseconds. E, F, or E is done the same way. And then the one that goes with the less than you don't have to go 1 minus your score. So let's just take a look at F. They want to know less than 90 milliseconds. So just quickly. Okay. If this is 68% and we want the 90, should we go by the Z-score or should we go by the other score? Your choice. Help me out. I want that area. Want that area? So let's find the Z-score. What's the 3 mean? How many standard deviations above the average are we? 3. Does a Z-score of 3.00 exist on our table A? Some of you got phones up. Please put them away. What do you think? Does 3.00 exist on our table A? Yes, so we go 3.00. We have 0.9987 for that value. So the area under the curve is 0.9987. Make this a percent. So we have 99.87% of all of our tests fall below 3 standard deviations below the average. Okay? That's all it is. So it's using that table. Yes, could you have done this by going, okay, we know that 100% of the population falls here and then break down into quadrants because it falls exactly on the standard deviation? Yes. Why would we do it that way? Not sure. Do it the same way every time. Find the z-score, go to the table in the back of the book. The table in the back of the book goes out to a little bit more than 3 standard deviations. Goes to 3.4 and to negative 3.4. Why does it not go much further out? Alex, you got it. You're getting phone up. Why does our z-score table only go to 3.4 above and 3.4 below the average score? Yeah, over that too much. So right there, what we have listed up there, going 3 standard deviations left, 3 standard deviations right, we're talking about 99.7% of the population fall within that. 99.7%, because you're not about 0.3 of the population. If you go a little bit further out, that 99.7 is going to approach 100% a little bit further. It's pretty rare to have something fall so far outside of 3 standard deviations. Okay? So F, G, H, I are all done the exact same way. Okay? Find the z-score. Refer to the table in the back of the book. It's already asking for less than, so you're talking about the area to the left. Okay, then we get to the letter J on worksheet 5.2. Letter J on 5.2. As long as the airbags inflate within 76 milliseconds, the passenger will be saved. In what percent of accidents will the passenger not be saved? I.e., the airbag does not inflate in time. Okay? So what percent showing this. So as long as it inflates within 76 milliseconds, the person, so if you have this, is this good enough for these airbags? Okay? So here's a question. Every car that's been out on the road, will every car out on the road get into a car accident? No. Okay? So, but you want all the airbags to perform under a certain amount of characteristics. So let's figure out what this will mean, and we're going to see what our population. So I'm going to go 76 minus my average over my mean, which was 10. So that's 16 over 10, which is 1.6. And a z-score of 1.6, somebody look in your table A in the back of the book, what does it come to? 1.60? Anybody? 0.9452. All right. Let's talk. Let's think about this. Yeah. Okay, so we looked at 1.6 right over here. 1.60. 1.60 is 0.9452. Okay. Question. Car makers. Question. Passengers in cars. Question to those who drive cars. If our airbags deploy, if 94.52% of the airbags that we manufacture in the car industry deploy fast enough that our passenger would be safe, is that a good enough statistic for our industry? Yeah. Okay, I heard a yeah and I heard a no. I want to know why the yeah. And both answers are right, but yeah, why? It was like a majority. Why else? I made a statement about 2 minutes ago about it, though. that's related. So why?
I don't know.
Go ahead, Winston.
I'm just thinking it would be hard to get a really more higher number than like 100%. It's hard to get. You can't get perfect percentages.
Can't get perfect. Okay, and someone said no. Who is the no? Okay, why? Talk to me. Everyone's got to be safe. Okay, so let's say in our developmental stage of this product, this came into a financial amount of money that was good for our industry. What do you think? Let's say that 94.52% of airbags, once deployed, will allow the passenger to be safe. Okay? So I want you to think critically about it. Will 100% of the cars on the road get in a car accident? No. Of those cars that are out on the road, right now, that 94.52% of them should deploy safely. Okay, but 100% of our cars out there on the road have a 94.52% chance that that airbag will deploy safely. Okay? Meaning, if it doesn't deploy that fast enough, you're too far into the dash for an inflated bag to make a difference. It'll probably create more harm. Okay? You guys know physics. Physics, you're driving an automobile and you suddenly stop because you run into something. Your body and everything else in that car wants to continue to move forward. Hopefully you all wear seatbelts will have some good effects on holding you in place. But hopefully that airbag deploys at a rapid enough rate that it's inflated by the time you hit the cushion. Okay? So is 94.52% a good enough amount for our industry?
Yeah.
So let me ask you this. What about that 5.48% that it's not good enough for? What is that called? The 5.48% that take too long. What is that called? No. What is it called? You guys know? Error. Good. And an error in industry results in what if someone's hurt? Money because of a lawsuit. So the industry that's creating these airbags, they're saying, okay, we want to make these airbags to create it safe. Is this a good enough number for us to know that under 6% of the accidents, that airbag will not deploy fast enough? Financially, if we get sued, will we be sued for a smaller amount of money than it will cost us to make this closer to 100%? Say it one more time. Think about it. If 5.48% of those airbags out there will not deploy fast enough, and someone is injured as a result, that turns into a lawsuit. That industry wants to know, can we afford this lawsuit if it comes? Is it a lesser amount of money lawsuit than it would cost us to develop this airbag to go faster? That's a real question businesses and corporations ask all the time. Should we roll the dice on this? You know, if to get this to a better amount is going to cost us $1 billion to do, I don't know if it will, but let's say it does, and this might result in lawsuits that are costing us $50,000. How many times does $50,000 go into $1 billion? A lot. Okay? So, does the corporation look at, is that good enough or not? And then the next question is, let's talk to legal. What's the most somebody could sue us for if they're injured by one of these airbags? And if legal comes back saying $50,000 is top dollar no matter what, then the car industry says, you know what? 94.52% is good enough for us. With the understanding that some of those airbags will not deploy fast enough to protect. Right or wrong? What is it? Ethically, right or wrong? Wrong. But is everything about business ethical? No. Business is in the business to make money. It's not always going to be ethical. Is there going to be a lawsuit that's created because of negligence on the part of a company? Yes. How big can that lawsuit be? And is the company willing to lose that money because it costs too much to raise the standard a little bit further? Should it piss you off? Well, if you're one of those 4.48%, yeah. But you know where else is going to tick you off? When you go buy a car going, okay, last year this car cost $25,000. I'm just picking a hypothetical value. But the following year, it's now $37,000. And you're looking at the car dealer going, what's $12,000 more? Oh, we made the airbag safer. Think about it. Who is driving this number to be where it's at? The consumer. Why? The consumer's not willing to go out and buy a Kia for $55,000. I'm going to go drop $55K on a car. I'm getting something a little bit better than a Kia. I don't know about y'all. But that means that everything else that's out there that usually costs $55,000 now is going to cost $70,000, $80,000 now. Is it worth the consumer going, you know what? I would have bought last year's model, but I'm not willing to spend that. So many factors go into this. Do companies want people injured by their product? No. Does it cost too much for that industry to make it a perfect system? Yes. Who's not willing to pay for it? The consumer. Why not? Because I don't want to spend my money. Not that much. Why don't I want to spend my money? Because my money's hard to work and make. I make good money. I enjoy my money. But I'm not willing to just hand it over to somebody. Okay? All right, almost done because I'm not going to go over both of them. If an airbag takes 64 seconds to inflate, what is the Z-score? So, letter K, if it takes 64 seconds to inflate, what is the Z-score? Well, the Z-score equation is this. Observed minus mu over phi, and we want to do 64 minus 60 over 10. What did I do? What is the Z-score? No. What is the Z-score? 0.4. What is the area under the curve? 0.6554. Is the Z-score different than the area under the curve? Yeah, the Z-score tells you how many standard deviations as a decimal you are away from the average. So we are 0.4 standard deviations above the average at 64 seconds. Okay? Then I can refer to my table in the back of the book to find out what percent is under that. Does that make sense? Okay, so a Z-score, you're finding some decimal amount. The Z-score tells you how far to the right and how far to the left the average would you be, and it goes with the standard deviation. It hand-in-handedly goes with it. Z-score, standard deviation, same thing. Usually standard deviation says we are 1 standard deviation, or 2, or 3. They don't give you a decimal amount. So the Z guys came into play saying, we'll give you that standard deviation, we'll give it to you as a decimal, you're 0.4 standard deviations above the average. Okay? So K, L, and M are all done the same way. And then last one that I want to work out, I'll actually work out N and O. They're both done the same way. So you have this, and you have this. Okay? N is your Z-score. Your Z-score on letter N, negative 1.62. What can you tell me about negative 1.62? That is the Z-score. What can you tell me in relationship to the normal curve? Where is it located? To the left or to the right of the average? To the left. How far to the left? More than 1 standard deviation to the left? More than 2? No, it is 1.62 standard deviations to the left of our average. What about O? 2.60. To the right or to the left of the average? To the right. Further than 1 standard deviation? Further than 2? Further than 3? No, it's between 2 and 3. It's 2.6 standard deviations above the average. All right, so this wants us to do a certain airbag has a z-score of this. What time does it take to inflate? So you know my z-score equation is this. Okay, same equation. So what letter is negative 1.62 in our equation? Z. Good. So I'm going to plug negative 1.62 in. I'm trying to figure out what that is. I know that this is 60. I know that this is 10. They gave it to us in the problem. So we know the average, we know the standard deviation. Okay? I'm going to multiply both sides by 10, so I'm going to get this. And then I'm going to do what? Add 60. So x bar, 60 added to negative 16.2 is how much? 43.8. I like it. So that says 43.8 milliseconds is how long that airbag would take to inflate. Okay? So notice I kept this negative. Stays negative as we go through. Okay? Let's go to this next one. Z equals x bar minus average over standard deviation. So what is 2.60 in this case? What letter? Z. I'm looking for my observed, and then my standard deviation we know is 60 from the problem. We know the our average is 60. Our standard deviation is 10. Multiply. So 26.0 equals x bar minus 60. What should I do? Add 60. What is that going to be? 86.0. So 86.0 milliseconds would be how long the airbag would take to inflate if we have a z-score of 2.6. Is it good? Do you see, does that make it, have you understand how industry is going to use this? Okay, you guys are giving me some critical thinking. Should critical thinking tick you off a little bit? Heck yeah, it should. Heck, we can't choose as a nation which is the better of the two sodas, Coke or Pepsi. Some are going to say Coke, some are going to say Pepsi. And some people are just like, you know what, it doesn't really matter to me, I'm thirsty, give me something to drink. Okay? Heck, we as a nation can't even agree on who should be president.
But we can agree because every 4 years we agree.
Only like.
I wish we all agreed. If this was discrete math, I would actually show you how. If this was discrete math, which is a great class, if you're going to take it in college, I loved it. It actually allows you to realize how the House of Representatives is distributed throughout the United States. Going, okay, why does this state have 8 people and this state have 46? And people say, oh, it's because of the population. Well, how much of the population? It changes. And then the House of Representatives allow you to get your electoral votes in. That, you guys know why we have an Electoral College? Let's tick you out as a nation. Might as well.
Spread out.
Huh? Say it. Say it, though. You might be right. Say it. Anyone know why we have an Electoral College? Why did the Electoral College cast votes? Yeah.
So it's spread out, not just one location.
Okay, kinda.
They didn't think Russian people.
What?
They didn't think people knew anything.
Oh, heck yeah. You know, when we created this nation, we got people that are farming and ranching and trying to raise families on the plains. They're too stinking dumb. They ain't educated. So we're going to create the Electoral College that's going to cast the vote for the President of the United States because the nation's too stupid.
But then you like narrow demographics and deal with like one class.
Oh, sure.
Plus, the final decision is up to us, then you're just kind of like, they just take it as input.
Yep.
It's like, oh, thanks for your.
Because we're too dumb as a nation to elect a leader.
That's why I'm popular.
You're like, wait a minute, I'm at Cherry Creek High School. I'm smart enough to. Yes, you are.
I don't want anyone deciding
Hey, I think it should be free pizza for all. That's the only thing I'm going for. All right. So we've already done this a little bit. Shh.
every state.
This is 5.3. I don't have to lecture all that much about it. Okay. Okay. Shh. So let's justify and clarify everything, because I know you guys had 4 days off. You did very little schoolwork, which makes you normal. I have no problem with that. So the z-score itself is just as a decimal amount how many standard deviations above or below the mean you are. Okay, when you use the table at the back of the book, will tell you how much area is to the left of your z-score. And if you want to find the area to the right, you go 1 minus whatever that decimal amount. So it'll give you that. So right now, if I use table A, oh, that's a bad curve. So z-score, so table A finds you that area. Okay? So table A finds you that area. Okay? So if I wanted to find the area over here, this is going to be 1 minus table A. Can't spell. Okay? So that's the ins and outs of it. Then we have to get to a point saying, okay, what if we know what the area is under the curve? How do we find the score that we're talking about with? Okay? Do I have to go off this? Can I go off something else? Can I go off the cuff? I'm making it up. All right. I'm going off the cuff. This is going to try and follow along with those, but I think it's going to give you the right idea. Okay. Now, I pissed us off as a nation originally. Now I'm going to make us happy as a nation. Is that right? As a nation, as the United States right now, you live in the United States, and you make, and I'm going to get my values about right, but I'm not going to be exact. I'm just going off memory. If you live in the United States, and your family is making $40,000 a year or more, you are doing better than 95% of the world. So if your family, you're talking if your mom and dad both work and they make more than $40,000 a year, you are doing better than 95% of the world. Now, I am almost positive that every family here in this classroom, I bet you your family, in some way, shape, or form, makes more than that. That right there is barely the new minimum wage. Barely. Okay? We are doing as a nation better than 95% of the world. Okay, you guys remember a couple years ago? People were all mad. They had we're going to sit out and cause industries not to be able to open because we're mad because the quote-unquote top 0.1% control this percent of all money. So you got people out there, and this is before the iPhone 5, so they have their iPhone 4s, they're tweeting that they're pissed off that these people make more money than them. You guys remember this? It was like 3 years ago, wasn't it? 2-3 years ago? So here you got these people tweeting on their iPhones that are doing better than 95% of the world. Meanwhile, you got a kid that's in some third world nation that's drinking water out of a puddle and eating flies for nutrition. But yet, let's occupy because we're mad. Wait, 95%? I'm doing better than 95% of the world? What the heck do I have to complain about? Life's tough. Oh, I get it. Life is tough. I'm pretty darn content with what I do. Here's my secret. And I don't know if you guys figured this out, but I love teaching. You know why? Because you all. Now, right now in my life, in my career, I have a hard thing going on because I teach only one math class. And I do have a medical class as well. But the most of my contract deals with teachers in other buildings who are teaching. But I have a hard time because part of me says, hey, I want 4 more classes of this. That puts me full-time in this building. Okay? But the other end of it is, wow, some of the things I'm doing has a direct impact on a whole bunch of kids. Gosh, what should I do? What's the balance of me? I will tell you that I am completely content with what I am doing, what I make, and what my family does. Am I going to complain about the 5% that's doing better than me in the world? God. I mean, when was the last time you scored a 95% on a test and you were like, you know what, I'm ticked. I got to figure out what 5% I'm not worth making. What 5% am I not getting to? All right, so 95%. Shh, real quick, almost done. I got a minute. What is this as a decimal? Help me out. What is this as a decimal? Okay, so let's go 0.9500. Still with me? So, here's the tough one. Real quick. Look back in your book. Look at your table. Find 0.9500. Relate that to your Z-score. We'll work more with this tomorrow. See you next time.